Hello everyone, how are you today? My name is Siddharth and welcome to the first tutorial on PCB design using Eagle CAD. Over the next few videos I will show you how to draw a schematic in Eagle and then generate the Gerber files that you can send to your PCB manufacturer to get your PCB fabricated. So let's begin. In order to get started you will need the Eagle software and you can download this from cadsoftusa.com. Click on downloads and you can download the Eagle software corresponding to your operating system. Now Eagle is available both as freeware and as a paid version, but in this tutorial I will be using only the freeware because well, it should be enough for most of your requirements. So once you download Eagle, install it in your system and open it, and it should open the Eagle control panel. This is what it looks like, and we're going to create a new project. And I'm going to call this first project. And once you created your project you need a new schematic, and this will open your drawing board and we're all set to add components here. To begin adding components to the schematic, click on this small icon over here and this will open up the existing libraries in Eagle, and there are a lot of libraries. So let's say you want to add a transistor, you can choose between PNP or NPN. Now, even though the libraries have hundreds of components in them, you don't have to worry about which component to pick because we will be using only standard values for all the components, at least for most of the components, and this should simplify your job of designing the schematic. We will begin by adding resistors to the schematic, and all resistors, capacitors, inductors can be found in the RCL library. Now, before we begin adding resistors, we need to understand how resistors are classified based on their power dissipation capability. Now, if you look at this picture over here, you will see the higher the power dissipation capability of a resistor, the greater its cross section will be. The power dissipated by a resistor is given by the square of the current times the resistance value. So a 1 watt resistor can allow a maximum of 1 ampere of current before it starts to burn. So you need to pick a resistor based on your circuit requirement. Now let me open up the data sheet of a quarter watt resistor. As you can see from the dimensions over here, the diameter is 2.5 millimeters, approximately 2 mm, and the length is 6.8 millimeters, approximately 7 mm. So in the RCL library, resistors are named like this, where DD corresponds to the diameter, LL corresponds to the length, and GS corresponds to grid spacing, which is actually the spacing between the holes on the PCB where the resistor is mounted. Everything truncated in millimeter. So coming back to our quarter watt resistor, based on the dimensions that we just saw, the standard quarter watt resistor is represented as 0207/10. Let's try to find that here. So here is our resistor and we will need to pick this for our schematic. Now grid spacing is something more of a personal choice, so there's no standard value involved here. Now similarly, a half a watt resistor has a diameter of 3 mm and a length of 9 mm. So in the Eagle library it will be represented as 0309, and you can choose different resistors based on the grid spacing value. Now some resistors have a V in the end, like this particular resistor, and a V means the resistor is mounted vertically on the PCB. Now vertical resistors have a different footprint compared to horizontal resistor. A footprint is basically how the component sits on the PCB. So this is the footprint of a vertical resistor and this is the footprint of a horizontal resistor, and you can clearly see that they both are different. Here's a picture of vertical resistor and horizontal resistor both mounted on the same PCB. Now let's go back to Eagle. Now the suffix EU and US, They represent Europe and US symbols. Now, the European symbol for a resistor is just a box, and the US symbol is a zigzag line. But both symbols correspond to the same footprint on the PCB, so once again, choosing US or EU is more of a personal choice. Now that we're done with resistors, let's look at how capacitors are named. Now, capacitors can be classified as polarized and non-polarized capacitors, and polarized capacitors can be found in the CPOL library, and polarized capacitors are represented like this, where E represents electrolytic, SS in this case is the lead spacing, not the grid spacing, and DD is the diameter. Now, most capacitors are represented as US E 2.5-7. At least that's the standard value. So let's try to find that capacitor, and there you have it. Now, you can always get the dimensions of your capacitor from the data sheet, or you can measure the dimensions yourself. And now that you know the naming convention, you can find the capacitor corresponding to whatever dimensions you have. Now, non-polarized capacitors have a slightly different naming convention, and they can be found in the CUS library. Now, this is how non-polarized capacitors are named, where SSS is the spacing and the last S is a decimal point, and W and L indicate the width and length, and the last letters again represent decimal points. The capacitor that I am using is CO50-035 times 0.75. Let's find that capacitor. Yeah, and this is my capacitor, and this capacitor has a 5 mm spacing, a 3.5 mm width, and a 7.5 mm length. Now let's look at a few other components and their standard representations. Now let's go to LEDs. Most common hobby projects use a 5 mm LED. So this is our LED, and if you're using male headers on your PCB, they can be found in the pinhead library. So for two headers, this is a standard package. Now, most surface mount devices, be it resistors or capacitors, are encased in 0805 packages. This indicates a length of 0.08 inches, not mm, and a width of 0.05 inches. The 0805 package is pretty much the standard for surface mount technology, so you will most likely be using this package unless your data sheet specifies some of the dimensions. First, let's look at the 0805 package. You have a picture over here. There you have it, 0.08 length and 0.05 inches width. Now let's try and find our 0805 capacitor. There you go, this is our required capacitor. So that's it for this tutorial. I hope you understood the standard values for most commonly used components. If you have any questions, feel free to email me or comment below. I will be adding more tutorials both on PCB design and circuit simulation, so subscribe to my channel. Thank you for the time, and I will see you in the next tutorial. Bye.